All right, you should have worked out this bookstore problem that says Wayne spent a third of his money on a pen and 4/7 of his money on books. What fraction of his money does he have left? Now note that this problem says what fraction of his money does he have left. So it tells you you're going to be dealing with a fraction. Sometimes though you might get a question that just says how much money does he have left? Well, if it hasn't told you any amount of money, we don't know how much money he has. It just says a third of his money and 4/7 of his money, so it didn't actually tell us the dollar amount. Since it didn't actually tell us the dollar amount, if it would have just said how much money does he have left, is it wanting you to give a dollar amount? And the answer to that is no, because we don't have dollar amounts, so we don't know what money that we're dealing with. So our answer has to be in fractions. So just kind of keep that in mind for when you're reading other problems and the question might be worded a little bit differently. So we've got a third of our money on a pen and 4/7 of our money on books. So again, here's our whole money, the whole. He's going to spend a third on pens. And then he's going to spend 4/7. And 4/7 is, that's crooked, but 4/7 is how much, or what's it close to? It's almost 4/8, and 4/8 is a half, so that's going to be a lot of money. So he spent 4/7 on books. How much does he have left? So, just like the one we just got through solving, we can add up and see how much more I need to get to a whole, or we can start with a whole and subtract back. We'll do it both ways so that you have two ways to do it. So you've got a way to check all your answers when you're doing these problems, okay? So we're going to start and say 1/3 plus 4/7. And if we're thinking about our equation, it would be plus what is going to equal a whole. And this what is what we're trying to find out. So let's start by third and 4/7. Can't add those together because they have different denominators. So you should have come up with a common denominator. And if we think about the multiples of 7, we can think 7, 14, 21, 28. The first one of these multiples that 3 will also have a multiple of is 21. Remember I said on the videos from yesterday that you can always say 3 times 7 to get your common denominator, but which on this case happens to be 21, which is the first one we came to. But sometimes you're going to have numbers that you can find a better denominator for, okay? Just as example, as a side note, think about if I was dealing with 6 and 4s. Well, 6 times 4 is 24. But I can think of a denominator that's less than 24 that it would be better to do that. What do you think it is? I hope you said 12. Because 6 can go into 12 and 4 can go into 12, and that's a lot smaller than 24. So don't always just multiply the denominators, okay? So let's turn both of these into 21st. So 1/3, to make the 3 equal 21, I've got to say times 7. So times 7 over 7. And 1 times 7 is 7. So 1/3 is the same thing as 7/21st. Is that how you would say it, I'm guessing? You wouldn't say 7/21, so 7/21st. And then I've got to do 4/7. So 4/7 to make 7 equal 21, we've got to say times 3 over 3. So 4 times 3 is 12. So 4/7 equals 12/21st. So 7 plus the 12 is going to be a total of 19/21st. I hope I'm saying that right. It sounds kind of funny. So we know that this part right here is that much. Obviously, we've got the whole, and our whole, since we're dealing with 21st, is 21 over 21. So if we've got 19 over 21, how much more do we need to add to equal 21 over 21? We need 2. Okay? Just like the one we had a while ago, that one also cannot be reduced because 2's only factors are 1 and 2, and 2 can't go into 21, so you can't simplify that any. So that was adding up, but I want us to practice subtracting back too, so that you've got another strategy you can use. So I need to say 1 whole minus 1/3 minus 4/7, and that's going to tell me how much is left. I'm not going to combine these and subtract them at one time because I basically just did that. I'm going to show you another way. So first I'm going to subtract 1/3. I don't have to start with 1/3. I could start with 4/7. It doesn't matter which one I subtract first. I'm just going to do thirds just because I happen to write first. So 1 whole, I'm dealing with thirds. 1 whole is 3/3. So 3/3 minus 1/3 is going to equal 2/3. So this part of my problem equals 2/3. Now I've got to say 2/3 minus the 4/7. 2/3 minus 4/7. Can't do that because they have different denominators. And kind of how we've already talked about, I can't say 3 times anything to get 7, and I can't say 7 divided by anything to get 3. So we already know from before we're going to do 21. So to get 2/3 to equal that, we're going to say times 7/7. And 2 times 7 is 14. And then to get 4/7 to equal 21st, 7 times 3, so times 3/3. And 4 times 3 is 12. So now I've got 14 21st minus 12 21st leaves me with 2 21st. So now I know I got the right answer both times because I came out with the same answer both strategies I used. So this is what I want you to do for the rest of math time. On my website under fractions, there is a game that is called, I think it's called Fraction Poker. But shh, don't tell anybody you're playing poker at school because that's probably against the rules. But I want you to go to that website and play that game for the rest of math time. Just hang on to this sheet and hang on to the sheets from yesterday. Okay? Bye.